Hey there, Mrs. Williams here, and this is a recording having to do with direct versus indirect proportions, and it's from the Module 2 practice exam. It says the volume flow rate measures the volume of a liquid that passes through a cross-sectional area per unit of time. This is an important measure in healthcare as it is used to measure the amount of blood pumping through a vein. The equation is given by Q equals V over T, where Q is the volume flow rate, V is the volume of the liquid, and T is the time. Part A, how are the volume of the fluid V and the volume flow rate Q related? Well, an easy way to tell how they are related is to look at where they are in the equation. Q equals V over T is like saying that Q is in the numerator, because you could put that over 1 if you wanted to, just to more easily see that Q is in the numerator and there's a 1 underneath. And so because Q and V are both in the numerator, they are directly related. So it's either going to be A or D. And the same would be true if they were both in the denominator. That doesn't occur as often, or you don't get that question too much. But if they're both in the same, either both in the numerator or both in the denominator, then those would be considered directly related. So part A says, okay, how do we interpret this? Or question, the rest of this is asking, how do you interpret this? So option A means that the volume of the fluid, which is V, increases the volume, let's try that again. As the volume of the fluid increases, the volume flow rate will decrease. So it's saying if this goes up, then this will go down. D, as the volume of the fluid increases, the volume flow rate will also increase. So it's saying if this goes up, will this also go up? So you could even try some numbers in here to see what would happen. So let's just say that V is 3 and T is 2. What would that mean about Q? That would mean Q is 1.5. 3 divided by 2 is 1.5. So let's see what would happen if I increase V. That's what both of these are saying. If we increase the volume of the fluid, what happens to the flow rate? What happens to Q? So let's say instead of 3, I put a 4 in here. What's 4 divided by 2? 4 divided by 2 is 2. That's bigger than 1.5. That means Q is 2. When we had a 3 here, it was 1.5. So that means it's gone up. Okay, let's try something even larger for V. V is increasing to 6, let's say. 6 divided by 2 is 3. Well, there again, Q has gone up. So anytime you have a direct proportion, if one amount increases, the other amount will increase as well. And that's what D is describing. So that's the one we want to go with. Okay, part B, how are the volume flow rate Q and time T related? Well, you might guess Q is in the numerator, T is in the denominator. That's an inverse proportion. So it's either going to be A or B. And then kind of based off of our example here, that'll help you interpret this correctly. What does inversely mean? So if the time increases, so if this goes up, what do you think will happen to Q if they're inversely related? We talked about here, if they're directly related, if this one goes up, this one goes up. So now that they're inversely related, if T goes up, Q is going to go down. Okay, so if the time increases, the volume flow rate, which is Q, will decrease. A would be the answer we'd go with.